Hi, I'm Dr. T and welcome to my office. So in the previous video I had talked about the sun's relationship to the earth, but I only talked about it on 2 days out of the year, the equinoxes. So what about the rest of the year? There's a lot more than 2 days in a year. Okay, so the reason I was focusing on the equinoxes is part of what I was talking about assumed that the sun was directly above the equator. That's only true for 2 days of the year. The reason this is only true for 2 days of the year is that the orbit the Earth makes around the sun, what we call the ecliptic, does not line up perpendicular to the axis that the Earth spins on. So for most of the year, one pole is pointed closer to the sun than the other. The axis stays and keeps its orientation relative to the background stars and everything else. So it, kind of slides around the Earth. So, imagine a stick, it's kind of doing this thing. It doesn't slide around the Earth, it slides around the sun. I know, terrible description. Moving on. Okay, so because of this, the angle that the sunlight hits changes because where on Earth is actually directly between the center and the sun depends on where in the Earth's orbit it is. So it's as if your latitude is changing daily, going back and forth over the course of a year. Okay, couple implications here. One, if you're trying to figure your latitude, this is kind of seasonally dependent if you're using it based off of the sun. Okay, good to know this. Second, that's going to be relatively relevant, is that the sunlight is hitting a little bit closer to perpendicular down to the ground some parts of the year, and a little bit further from perpendicular, a little bit of a steeper angle. Now, if you remember, that's why higher latitudes are typically colder. The sunlight hits them at a shallower angle than lower latitudes, which are close to the equator, and the sunlight hits that at a higher angle. Closer to straight on, whatever those words would be. Because of this, the temperature changes, and we know this as seasons. And so seasons are incredibly important, especially if you are away from the equator and your seasons are fairly dramatic. So for really anyone, but definitely for anyone who is tied to the land, an agrarian or hunter-gatherer society, if you have to be dependent on plants growing, etc., and honestly, people today still are, those who work with plants, then you need to know where in that cycle you are to know what you need to do. There are certain times when you need to put seed in the ground. Other times you need to harvest the plants because it's going to get cold and the plants are not going to make it through the winter. So, okay, this is because of where we are in the Earth's orbit, because the Earth, once again, isn't, perpendicular. The axis of the Earth's rotation isn't perpendicular to the orbit. Now, to figure out where on Earth's orbit you are, and hopefully, predict what you should be doing with your plants and whatnot, is to look at where the sun is. Now, you could look at how high at the sky it is at noon. However, that's a little bit more temperamental than one would hope. Once again, remember, you don't want to look straight at the thing, and shadows help, but they're kind of small. A somewhat easier approach is to actually look at dawn and dusk. Now, not only does the sun raise and lower its height during the day, what it will also do is, as it comes up in the east and sets in the west, only during the equinoxes does it actually come up due east and due west. Remember, the Earth is at an angle relative to the sun for most of the year, except for the equinoxes. Because of this, one side of the Earth gets more light for a longer period of time, actually, once again, increasing the fact that it's going to be getting warmer. Not only does the light come in a little bit closer to straight on, it stays light longer because that end of the Earth is pointed closer towards the sun, and thus, it's less of it's in shadow. I'll try and do a photo that makes a better description of what I just said. So depending on the angle of the Earth relative to the sun at that given day, depends on exactly where the sun is going to rise and set. So if you, say, have an observation post and have a couple of markers, then you can look where the sun rises and sets on different days of the year. That's telling you what's going on. So if you had to have, say, one due east, one due west, that would tell you when you're at an equinox, and then possibly ones for, say, summer and winter solstices, which are the point where you're at the maximum angle, and thus you're going to be arcing back around, and the seasons are going to be switching over. Okay. If you look at a lot of ancient stone structures, those big megalithic sites, they're like, ooh, cool. These kinds of alignments are fairly common. This almost certainly had spiritual meaning to the individuals who built them, but it also definitely had a practical application. You knew that when the sun pointed, over here, it illuminated between these two, then it was time to do this, that, or the other thing. And we've actually found quite a few caves that, of course, predate a lot of these big stone structures, where the artwork that gets illuminated for part of the year because the sun's angle is correct because of the orientation of the earth, happens to be of animals that would have been available during that time of the year. And thus, hey, we can tell time with respect to seasons. Of course, this is incredibly useful and probably led to a lot of the beliefs around the sky's predictive future, good old astrology, which, I'm sorry, you can look at the sky to figure out the seasons. You're not going to figure out who's the best lover. Sorry, it's not going to work. Now, of course, you do have another option if you're trying to figure out seasons. Instead of looking during the day, you can look at night. So you can look at the stars. Ancient peoples all the way up through today, in order to help memorize what's where, look for patterns. And even though the stars are kind of randomly out there, for the most part at least, we draw lines. And so these lines are constellations, and that helps us remember which star is which. That way, if we want to use something for our benefit, then we can do so. Now, because the Earth is going around the sun, and because you only can really look at the stars at night, you're only going to be able to look at the stars that are opposite the sun. Now, the stars aren't orbiting the sun. Therefore, they're going to just kind of sit there, and you're going to sweep around, so which stars you can view depends on where in the orbit you are. And thus, knowing which stars you can see, is going to tell you what season you are in. And so another way of predicting when in Earth's orbit you are, and thus telling you what you need to be doing with respect to a lot of the natural world. What animals are going to become abundant, when you need to be storing food, that kind of thing. So the angle of Earth's orbit relative to its axis, definitely a useful thing to keep in mind. Makes a big impact for our lives, especially for those of us who live away from the equator. If you're close to the equator, it doesn't change much, so it's just kind of season, and you're more concerned with things such as monsoon versus dry season, that kind of scenario. But with that said, have a wonderful day.